All right, so we're going to review some algebra we did last year, specifically expanding and the reverse of expanding, which is factorising. Yeah. So, yeah. So, as in 6 is 3 times 2, that's it expanded. And factorising is then, these are the factors of 6. Okay. Right, so Okay, so this is two binomials or two number brackets, and they have to expand them, multiply. We should be able to do this. Try and do this faster than me. So we're going to start with expand. Write it down in your book, the answer. So some people have a FOIL method or some other method. So expanding double brackets, everything must be multiplied by everything else. 3 times 4 to gives 12. 3 times 7x to give 21x. These two in the middle multiplied to give 8x. And these final two multiplied to give 2 times 7 is 14. And x times x is x squared. And usually we tidy it up by putting the largest power of x first, 14x squared. Add these two like terms together to give 29x. And then plus 12. Okay. That's a pretty common one. And another one is expanding a square bracket that we'd have to do. So something like 3x plus 2 squared. Am I able to expand that? Yeah. So some people expand it by writing it twice. So a common mistake is to just say 9x squared plus 4. It is more than that because everything must be multiplied by everything else, and it's the same process of this then. A 4 multiplication process, 9x squared, these two multiplied, plus 6x, and another plus 6x with the middle two here multiplied, and then the last two multiplied plus 4, and I get 9x squared plus 12x plus 4. And that's two simple examples of expansions. Okay, let's look more towards, kind of in the expansion. Oh, these pens are bad. Realm. What's the difference of two squares? Have we heard that before? Difference of two squares. Okay. Difference of two squares is the expansion factorising technique that involves two squared. So something squared and something else squared. The difference would be minus. A squared minus b squared. When we see something like that, that's called the difference of two squares. How does that factorize? It factorizes like this: a plus b, a minus b. That's the classic difference of two squares. It will expand this way. It's expanded, and it factorizes this way. Okay, so if we see something like 16x squared minus 9, we may not remember this, but we should be able to factorize that easily because we notice they are two squares. I'm actually going to get rid of and put the brackets a bit lower. We're going to look at what would be the square root of this, let's say. What times what gives 16x squared? 4x, yes. So 4x squared, and what times what gives 9? 3. So it forms this, a squared minus b squared, difference of two things that are squares. So something that is square can be square rooted. So if this number was not 16 and it was something like even 15, it wouldn't be difference of two squares because no number squared gives 15. So they must both be squares. This is special factorization. And you would 4x minus 3. Or we put plus last time, so let's put plus first. It doesn't matter which one you put around, and 4x So 1 minus 1 plus, like this. Now you could factorize this by having a 0 term in the middle. Maybe you remember it this way. If we have 16x squared minus 9, and we say, how do I factorize this? And you say, well, that looks a bit like a quadratic, but not quite. If I put in a 0 term in the middle, then I can try and factorize it like a normal quadratic, where I have 4x and 4x. Okay, they multiply to give this. Then 3 times 3 gives 9. And then what signs must they be to make 0 in the middle? Well, this one gives 12x. This one gives 12x. So in order to cancel out in the middle, one must be plus, one must be minus. It's the same principle here. So that's called difference of two squares. If that's the first time you've heard that expression. Shouldn't be, but. All right, so these are special cases of expanding and factorizing. Another one is a perfect square. Perfect square, which is this. It's called a perfect. So what does this give when it's squared? Well, you could work it out. A plus b times a plus b. The a's will multiply to give a squared. This gives plus a times b is just ab. A times b is just ab. And these two, b squared. So we get a squared plus 2ab. These two together is 2 plus b squared. And it's this way. So if you ever see the term perfect square, that's this is it expanded, going this way, and going backwards would be it factorized. Now they are both kind of special cases of quadratics. We're probably more used to just solving or factorizing quadratics without these two special ones, and they are the more likely one to come up. Okay, so if I have something, I want to factorize this. I need to be able to factorize this. What's the first step in factorizing a quadratic that we use normally? First thing we write down? Okay, yeah. So, yeah, you're talking about multiples of 6. I usually put the brackets first. And then I think of two things to multiply to give x squared, x and x. All right, and then I think of all the factors of 6. So they have to be in pairs, 2 times 3 or 1 times 6. There's my two options I can use. These numbers go here and here. Which one I pick? Yeah, I look at this one and I go 2 and 3. No, you can't do both actually, because of the signs. Yeah, if that was minus 5, you'd use 6 and 1, because 6 minus 1 gives 5. But because it's plus, we have to add. So let's go 2 and 3. And now my test for this, which you may not use, or you can use a different one, I always check to see the multiplication. Because when I expand these, I end up multiplying this all out. So these two, when they're multiplied, gives 2x. These two, when multiplied, gives 3x. And I go, I need to make this middle term. So plus 5x. How do I make it? Well, they both must be plus. And that's my system to do it. And that's it factorized. That's a relatively straightforward example. Let's do another one. What have I written down here? More difficult one. Let's try this one. 14x. Is that minus or plus 34? Okay. Okay, so we're going through the same system again. Factorizing a quadratic is a very important skill to be able to have. Same system. Open up a set of brackets. think about what makes x squared. Okay, once it's x squared, it's easy enough. It's x times x. And then I go to my 24, and I think factors of 24. There's a number of them. 1 times 24, 2 times 12, 3 times 8, or 6 times 4. Now, it mightn't always work to get the first one. Like, you might pick, and it might actually be wrong. So let's say you pick 6 and 4. Don't take this down if you're taking this down. 6 and 4, multiply to give the 24 at the end. Perfect. But do they make the 14 in the middle? Well, that makes 6x, and this one makes 4x. Is there any way of combining those, adding or subtracting, to make 14? No. Okay, I've made a mistake, so I must go back and pick another one. Looking at it, which one should we pick? 12 and 2 makes sense. Yeah. So x plus 12, x plus 2. We can do our tests on it, but I think you'll get 14 factorized. Okay, let's do a more difficult example. It gets more difficult when we got a coefficient here in front of the x squared. So I have 2x squared plus 18x and plus a 40. Factorizing this. Okay, let's go through the same system. What do I put here and here this time? 2x and x, okay. Now 40's got a bunch as well. We've 20 times 2, 1 times 40, 5 times 8. Any more? 4 and 10, yeah. Okay. Now none of those combine to make 18. None of them. But we got to use the 2. Yes, it's 2 times. So which one do we use? So you're saying 20 and 2? Okay, let's test. That's 20x. And that's 4x. Are they going to ever make 18? No, they'll make 16 or 24. Okay, so we try again. It's 5? All right, I hear 4 and 10, and it's been dismissed. Maybe it's right.
No, but you do it the other way.
Okay, 10 and 4. So that makes 10x. That makes 8x. If they are both positive, they do make 18x. Okay, that works. What was the other one? 5 and 8?
Oh, yeah,
So 5 goes here?
no.
No. Yeah. 8 goes here, 5 goes here. Okay, how is there 2 answers? Does that mean this has 4 different roots? Because what are we getting here when we're factorizing? We're on the way to getting something. We're on the way to getting a solution where it crosses the x-axis, aren't we? This is what we're getting. We're getting here and here. We just don't finish it. But that's what we're getting. The one we just did, it seems like there's 2 possible answers, which means, does this cross at 4 places and therefore is not actually a quadratic at all? Well, let's look at the 2 answers again. Ozzy's answer was different. Ozzy's answer was, I forget what it was.
4 and
2x plus 10 here.
Yeah.
Are they 2 different answers?
They make the same answer.
Now, if we finish this off, yes, they make the same answer. If you finish this off, this makes x equal to minus 5, doesn't it? If you finish it off to get the solution. And this one makes x equals to negative 4. If we're doing, it's the same answer. And this equals x negative 4 because 2x would equal minus 8. And so would that. Is there anything we could have done to this equation to make it easier at the start? So both answers are correct, yes. A good first step, if anything has a common factor across the board, is to simplify first. So I could have taken 2 out and gone x squared plus 9x plus 20. And that would have made it easier for us to solve. If I can, always take out a common factor. Do I get the same answer? Yes. x and x make the x squared. 5 times 4 make that and plus, and I end up with the same answers. Minus 4 and minus 5. It's the same answer. Because x plus 4 is the same as 2x plus 8 when the 2 is out here. It's the same answer. Okay, there was one other type which was kind of off kilter here. The first one was that if there's 2 terms. Remember that the difference of 2 squared, it was like 2 square terms. We had 16x squared minus 9. That's 2 terms. These quadratics all have 3 terms. What was the type that had 4 terms? It had a special name to factorizing when it had 4 terms. So 1, 2, and another 2. It's called factorizing by grouping. Factorizing by grouping. If there's 4 terms. So it's called by grouping. Let's see, let's give an example I have here. X squared plus 3x minus x minus 3. This is kind of a forced one. You could combine this and do it otherwise, but how do I factorize this by grouping, a 4-term factorization? What was the process again? Can you remember? Yeah. So you do it in 2. So what's the factorize these 2 separately and then put them together afterwards? What are you expecting? So common factor here is x, and we're left with x plus 3. What's the common factor here? You take out negative 1. Why? Because you want to have x plus 3 as your second bracket. These 2 brackets have to be the same for it to work. So they need to be the same. Once they're the same, what's the final step in the factorization? Yeah. Both x plus 3 is multiplied by x and by minus 1, so we can say that it's multiplied by x and minus 1 times x plus 3. So the x minus 1 comes together in one bracket, and the x plus 3 only needs to be written once then for the second one. And that's 4-term factorization.
Did we learn this?
Yeah. We being most people in the room. Kayleem, I'm not sure. Okay. All right, so that's pretty much all expansion and factorization. When it comes to factorization, the first thing you should look for is what? If there's a common factor to all. Remember that 2 that could have been factored out of everything? Okay, so if you can take out a common factor out of all terms, take it out first if you're factorizing. Then, then it's kind of a few paths. You're going to, if it's 2 terms, look for difference of 2 squares. So that's a minus b, b minus a squared. That was one of the ones we had an example of. So you would set up that and get the 2 brackets for that. If it's 3 terms, it could be a perfect square, but you can always find a perfect square by by the quadratic technique. When I say quadratic technique, I mean what we did for, we opened up the 2 brackets and we filled in here and here, x times x, and we filled in 3 and 2. That's what I mean by the quadratic technique. If you ever see 3 terms. It might end up being a perfect square, the same thing squared, but that's okay. And if it's 4 terms, it's called by grouping, which is this example over here. Do 2 and 2. The first 2 and the second 2. Okay, that's after you've taken out a common factor of all terms, if possible. Okay, there's a review of this on ManageBack with the answers. You can get cracking on that now.